All right, let's look at example number 3. So we have find the centroid x bar, y bar of the region bounded by y equals 5x squared plus 2x, y equals 0, x equals 0, and x equals 3. So let's take a quick look at what that graph is going to look like. And you can go through and mathematically figure out easy enough what that vertex looks like, but for the sake of time I'm just going to tell you it's at negative 1/5 and 1/5. Negative 1/5, negative 1/5. And then we have y equals, I'm going to factor out an x so we can find those zeros. And then 0 is a 0 and 2/5 is a 0. And so pretty steep parabola. And then we're going to go out till x equals 3. Not really to scale, but we get the idea. So this is the area of the lamina that we want to find. So we want to find the center of mass of that area right there. So first of all, to find the total mass, our total mass is equal to rho times the area. So to find the area, we're going to take the integral from, in this case, 0 to 3. That's our x values from 0 to 3 of, from 0 to 3 of rho times f of x times dx. So let's fill all that in. So we get from 0 to 3. We can put rho out in front because we do know that that's going to be a constant. We are also going to set it equal to 1 because they do not tell us what rho is in this case, so we're going to assume that it is just 1. And then f of x is equal to 5x squared plus 2x, which is the height at each x value, and then dx, which is the width. Now just go ahead and do that on your calculator. And your answer should come out to be, let me pause here a second, I'm lost in my notes. Okay, I found it. So it is 54. Alright, next one. So now we want to find what our moment with respect to x is. So now our moment with respect to x is going to be the integral 0 to 3 of our total mass, or no, just our mass, sorry, our mass times the position. So our mass in this case is rho times the unit area, or times the area, which was f of x dx. And then for our x position, we're going to say that that is at the centroid, which is at f of x over 2. So that's going to give us the integral from 0 to 3 of rho. Put rho out in front. Again, we're just going to say that rho is equal to 1. This is going to be f of x squared. So I'm going to take f of x squared plus 2x squared, and square all of that, dx. And then we also have a 1/2 here also. So don't forget that 1/2. So now again, you can do that on your calculator. When I did this on my calculator, I did not re-enter the equation. I just left my y as 5x squared plus 2x. And then when I went in and did my integral, go under math, hit 9, and then I did 0.5 times, go into variables, select your y sub 1, or wherever you have it at, and then square y sub 1, and it actually works. And then you can do comma x, comma 0 to 3, and after all of that, you end up with 828 for your answer on that one. Okay, and then for m sub y, we're going to have the integral from 0 to 3 of rho times x times f of x. So our mass is rho times f of x dx, and then the position is x in respect to our y-axis. So we're going to end up with rho, which again we're just going to say that's 1, and then the integral from 0 to 3 of x times f of x, which is 5x squared plus 2x dx. Okay, and again, you can do that one on your calculator. You already have the y equals 5x squared plus 2x in for y, and just go into your math, hit 9 for integral, and then do x times your variable y, comma x, comma 0 to 3, and it works. It gives you a really quick answer. And the answer to that one is 477 over 4, it looks like. 477 over 4. So then to find our x position, our x bar is going to be equal to our moment with respect to y over the total mass, which is 477 over 4 all over 54. Which is 2.2083, and then y bar is equal to the moment with respect to x over m, which is the total mass, and that is equal to 828 over 54, which is equal to 15.33. What happened? Okay, so the center of mass, let me get a different color, is going to be about 2.2 and then 15. I didn't really go by my y-axis. I didn't really draw my y-axis to scale, but somewhere right in here is going to be the center of our mass. And then you have x bar and y bar, and that's your solution for example number 3. Okay, now we're on to example number 4. So find the centroid, x bar, y bar, of the triangle with vertices. So let's draw this out real quick. 0, 0, 6, 0, 6, and 0, 9. Okay, so here's our triangle, and we want to find the center of mass of this triangle at x bar, y bar, so this whole thing. Okay, so what we need to do is, the first thing we need to do is we need to know what the equation of this line is. So to write an equation for that line, remember we're at 9 and 6 there, it's going to be just y equals mx plus b equation. So our slope, we have the rise, we have the start at this point, which is our b value, is 9, and then we would go down 9 to the right 6. So y equals 9, negative 9 sixths x, it's really hard to write sideways, plus 9. Okay, and so that's our equation, and we can simplify that a little bit too. So negative 9 sixths x plus 9 is equal to negative 3 over 2x plus 9. Right, so from there, first thing that we want to do is find our total mass. So we're going to go from 0 to 6 of rho, which, yes, we're just going to say that that is 1, but we need to remember that it's there in case we ever given an equation that rho is more than 1, or they actually give us a value of 4, times f of x, which is negative 3/2 x plus 9 dx. And then you can go ahead and find that in your calculator. Then the next one we need to find is the moment with respect to x. Let's put the row out in front here this time. So we go from 0 to 6. The moment of x is going to be squared, f of x squared, and then over 2. F of x squared over 2. We can also bring that 2, since it's a constant, we can also bring it out in front over under the row. And then again, we're just assuming that row is 1. And again, you can find that on your calculator. Okay, I'll come back here and write all those answers in a minute. And then the last thing that we want to do is find the moment with respect to y. The moment with respect to y, we're going to have from 0, the integral from 0 to 6 of x times x, f of x. Dx. Okay, look for all those answers. And so we have 27 for the total mass. The moment with respect to x was 81, and I just used my calculator to find all of these. Just like I told you in the last one, just put in your y equals this equation right here into your y equals part of your calculator, and then you can use that y variable to add and square and everything else that you need to do to it. Okay, so then we have x bar is equal to 54 over 27, and y bar is equal to 81 over 27, and this one actually works out really nicely. We get x bar, y bar is equal to 2, 3. And that is a point that I can graph here. So change colors again. So we'll have 2, 3, and then that gives us the center of mass of that triangle.